Hi, this is Dana from the Wheaton Library. Welcome to 3D Printing. What, why, how? Today we'll discuss what 3D printing is, why you might need it, and how you can learn it. So what is 3D printing? It is the making of parts and products using a computer-driven additive process, one layer at a time. 3D printing builds parts out of plastic, metal, ceramics, and other materials directly from CAD drawings that have been cross-sectioned into thousands of layers. Wanted to give you a brief history of 3D printing? In 1981, Hideo Kodama invented two additive methods for fabricating plastic models. In 1984, Chuck Hull filed a patent for a stereolithography fabrication system. Stereolithography is the process of adding layers through an ultraviolet light laser curing technique. In 1988, the technology used by most library 3D printers, FDM, which stands for Fused Deposition Modeling, was created. In 1993, the actual term 3D printing was coined, though it refers to a process involving custom inkjet printheads and was developed by Emanuel Sachs at MIT. In 1999, the first 3D printed organ is implanted in a human. In 2008, the first usable 3D printed prosthetic leg was created and used. In 2009, the FDM printing patent expired. This, combined with the growing popularity of Kickstarter and crowdsourcing, allows for wider development and innovation of 3D printers. In 2011, the first unmanned 3D printed aircraft was created for a total cost of $7,000. In 2015, affordable bio-ink, which can be used for printing tissue and cartilage, is used for the first time. And in 2021, 3D printed houses, 3D printing in space, and 3D printed human organs are all realities. So why would you need 3D printing? One possibility is architecture and construction. The advantages to using 3D printed architecture include the fact that the materials are environmentally friendly. Raw soil, natural waste from the rice production chain, and other plastics can be used. It's also inexpensive. There are shorter construction periods, and you can use uncommon shapes. The house you are viewing right now is called TECLA, short for Technology and Clay. It is a 3D printed habitat created entirely of reusable and recycled materials. It was created by using multiple 3D printers running simultaneously. The total printing time was just over 200 hours. Another way that you could use 3D printing is through medicine. Bioprinting is an extension of traditional 3D printing. It can produce living tissue, bone, blood vessels, and potentially entire organs. The process uses bio-ink, which uses cultivated cells from a patient, as well as organic gel scaffolding for stabilization. 3D printing can also be used in medicine, in particular prosthetics. The affordability of 3D printers has driven down the cost of prosthetics, which traditionally cost between $5,000 and $50,000. In comparison, the e-NABLE community provides 3D printed hands and arms for $50 to those in need. Art and fashion is one surprising use of 3D printing. There are complex geometric pieces and giant sculptures that have been created with 3D printers. The piece that you see on the screen weighs 597 pounds and took 1,780 hours to print. The Virus art program uses 2.5D printing to reproduce the great works of Monet, Vermeer, or Van Gogh. The piece that you see on the screen is The Iris by Van Gogh. Footwear companies are creating customized soles and uppers, making perfectly fitted shoes. And while garments can be built and printed, the flexibility of the material required makes the cost prohibitive, though you may see it on runways. The automotive industry is also taking advantage of 3D printing. Automotive companies use prototypes of brake discs, gas pedals, etc. BMW and Bugatti produce end-use parts such as a folding roof mechanism, rims, or brake calipers. And the body of the car that you see on the screen, the EDAG Light Cocoon, is printed entirely using 3D printers. You'll see 3D printing used in aerospace applications as well. The International Space Station has its own 3D printer. It produces tools that are too expensive or risky to transport from Earth. The image at right is from its test flight in 2014. Construction in space is difficult because Earth materials are bulky and very expensive. Scientists and researchers are looking into the possibility of using moon dust, meteorites, or regolith, which is the sandy dust on Mars, as construction materials. Bioprinting is in the experimentation stage in space. NASA astronauts have created heart-like tissues in space. The lack of gravity makes scaffolding obsolete. If you recall, scaffolding needs to be used to construct human organs because of the spaces inside. And how do you learn 3D printing? How do you design in 3D? Step 1 is to choose your own design software. I've listed 3 choices on the screen, though there are certainly more. Each of these programs are fairly similar, but each has its own pros, cons, and individual quirks. The Wheaton Public Library does offer a class to help people learn how to use Tinkercad. Make sure you take advantage of the tutorials. Each one of these software applications has tutorials available for free, and they are invaluable as far as learning how to use and design in 3D. What you see on the screen is an example of the work plane in Tinkercad. The work plane can be rotated on all angles and even viewed from the bottom so that you can see all sides of your product. In Tinkercad, you can use the Shapes tool to create building blocks for your design. Use the pull-down on the right-hand side to select from a variety of categories such as basic shapes, creatures and characters, and everyday objects. You can add more shapes to customize your design. Ultimately, you can build whatever you like by stacking shapes on top of each other. Once you're finished, you can rotate the design to make sure it looks correct from all angles. Designing in 3D. Most apps have pre-made shapes to help you begin. I already mentioned in Tinkercad that you can create a variety of different shapes. Each shape can then be stretched or changed indefinitely. All 3 of these objects began as the sphere on the left. You can use the shapes to create different objects. The shapes on the left were stacked on top of each other to create the orange chess pawn. Once you've designed your object, the next step is printing it. You can use the Wheaton Library's 3D printer, which is located in the Tech Center. Start at the following address, wheatonlibrary.org/3dprint. Then upload your design using the steps listed on our webpage. The library staff cannot create a design for you. However, they will verify that your design can print correctly and work with you to edit any issues that they find. 3D materials. The library uses PLA, which stands for polylactic acid filament. It is made from fermented plant starch, such as corn, cassava, sugarcane, or sugar beet pulp. These types of plastics are known as bioplastics. The filament comes in a spool, which is then loaded into the printer, and is then heated, fed through a nozzle, which results in smaller pliable strings as small as 0.4 millimeters, and that is used to build your design layer by layer. The Wheaton Library 3D printer is a Dremel 3D45. The maximum size of a finished product is 10 inches by 6 inches by 6.7 inches. Printing costs $1 per file, plus 10 cents for every gram printed. Designs are limited to one color only, but you can choose from white, black, red, blue, green, orange, pink, purple, gold, silver, or translucent. Some 3D designs require additional support. You want to watch for overhangs and bridges. Anything with a greater than 60-degree overhang will generally need support. You can see an example in the picture on the right. Supports are only used during the printing process. and you'll need to take the extra step of removing the supports once the design is finished printing. Most 3D designs take at least an hour to print. Keep in mind that your design may not be ready for pickup for several days. Thank you for watching. Make sure to visit the Tech Center to see the 3D printer in action.